Alright, so this kind of goes along with our simplifying radicals. We learned how to simplify radicals when we got into our radical unit, and we remember when we simplify a radical, you have to get it in its simplest form, so no perfect squares can be inside of the radical, so you can pull this out. This is going to be similar to that, except for now we're going to be multiplying and dividing the radicals first or after. Okay? Alright, so the products of radicals, we multiply the numbers that are both on the outside of the radical, multiply the numbers that are both on the inside of the radical, then we simplify our answer. You can either simplify beforehand or after. It's really up to you. Okay? Alright, so we're going to multiply 6 times 8, and we're going to get 48. So this is going to be the square root of 48. So now, this is almost identical to just simplifying radicals. We need to find a perfect square that can go into the largest perfect square that can go into 48, which would be 16. 16 times 3 is 48. And we know the square root of 16 is 4. So this becomes 4 square root 3. So the only thing we knew there was multiplying first. Alright, so we're going to do the same thing here. So we're going to multiply the outside and inside. So we're going to multiply 2 times 3, which is 6. And 3 times 5, which is 15, and a times a, which is a squared. Alright, so can 15 be broken apart into 2 perfect squares? No. 3 and 5 aren't perfect squares, and those are the only things that multiply together equal 15. How about this a squared? Can I square root a squared? Yeah, it becomes a. So this becomes 6a on the outside, and then the square root of 15. Alright, so this one, we can either find the square root of 4 first, or I can multiply first. I'm going to multiply first just in case I don't make any mistakes, okay? That's really up to you. So I'm going to have negative 2 on the outside, and then what's 27 times 4?
108.
Okay, now I need to break apart 108. And 3. Right?
Yeah.
So I'm going to, what's the square root of 36? And negative 2 times 6 would be negative 12 square root 3. So I could have found the square root of 4 first, and then broken apart 27 and then just multiplied it. It's really up to you how you'd like to do it. I'm afraid if you square root 4 first, you're going to forget to multiply the 2 by the number. So I could have done it like this. I'll show you. So I could have done negative 2, then 27 breaks apart into 9 and 3. And then this would have been times 2 because the square root of 4 is 2. So this would have been, 9 would have came out. This would have been 2 times 3, square root 3 times 2. Negative 6 square root 3 times 2, which would be negative 12 square root 3. So that's the other way you could have done it. I don't know if it's easier for you guys. I'm afraid that people might forget to multiply by the 2.
I was thinking about the 2 times
I just square rooted 2. Yeah, negative 6 times 2, which would have been 12. So there's 2 ways you can do it. But I'm afraid you would forget to multiply by this 2. That's why multiplying first is sometimes easier. Okay? Alright, so that's product rules. It's pretty simple. It's just exactly the same as what we did. We just multiply first and then simplify, or you can simplify first and then multiply. With the quotient rule, so with quotients of radicals, there's a new rule here. You cannot leave a radical in the denominator of any fraction, okay? So there's multiple methods that can be used to remove the radical in the denominator. Our first method is if the number in the denominator goes into the numerator, okay? So if the number in the divider, not talking. and the denominator divides into the numerator, then we just divide first and then simplify. If it doesn't, then we're gonna learn that on the next slide, okay? So 2 can go into 40, makes the square root 20. And we can break apart 20 into the square root of 4 times 5. And what is the square root of 4? 2. So this becomes 2 square root 5. Okay? Just because it's broken apart doesn't mean that's anything different other than it's the same thing as this. I can still divide 2 into 18 and get the square root of 9. And the square root of 9 is 3. Okay? And then 12 divides into 96, making this the square root of 8. And we can break 8 apart into 4 times 2. And the square root of 4 is 2 square root 2. That's if the denominator goes into the numerator. However, sometimes we're not so lucky and that doesn't happen. So if for all other cases, we're going to take the square root and or simplify the square root. So we're going to simplify everything first. And then maybe something then can cancel out or something can go into it, something else. But if not, we're going to rationalize the denominator. What that means is we're going to multiply the top and the bottom by the radical. And then we're going to simplify / reduce. Okay, so 3 cannot go into 4. But I can break this apart between the square root of 3 and the square root of 4. What's the square root of 4? 2. So this would be the square root of 3 over 2. The only thing is we can't have a radical in the denominator. I don't have a radical in the denominator, and everything is simplified. So it'll just remain just like that. All right. Can 18 go into 5?
No.
Can 5 go into 18? No. Okay, so there's no simplifying I can do. I can break apart 18. Yes. 9 times 2. This is the square root of 5 over the square root of 9 times 2m. So this has become the square root of 5 over 3 square root 2m. Alright. So everything's reduced, but there's still a radical in the denominator. So this is when we have to rationalize our denominator. So we're multiplying both the top and the bottom by the radical. So my radical on the bottom is 2m. So I'm going to multiply the top by 2m and the bottom by 2m squared. Okay? So I'm going to get 10m on top, or the square root of 10m. And then I'm going to get 3 square root 4m squared on the bottom. And we can square root 4m squared, which would be 2m. And 2m times 3 would be, what? 6m. And we have the square root of 10m on top. So I do not have a square root on the bottom, and everything is simplified. All right, can 50 go into 32? No. Can 32 go into 50? No. Can it break apart 32 and 50? Yes. I can break apart 32, can become the square root of 16 times 2. And 50 can become 25 times 2. And what is the square root of 16? 4. Square root 2. What's the square root of 25? 5. Square root 2. I have the same thing on top and bottom, so this can just cancel out or reduce. So I get 4 over 5. Okay, can x go into x cubed? Oh, yeah, it's 3 of them, so there's 3 x's there. So yes, one of them. We can use our quotient rule of dividing where I subtract my exponents. So I'm going to get the square root of x squared. And what is the square root of x squared? X. Okay. Can 6 go into 3? No, the 3 can go into 6. So I can either, there's two ways I can do this. I can either reduce by bringing my numerator into my denominator. However, that's not going to really help me because I'm going to still have a radical in the denominator. So I can just rationalize my fraction now. So I can take my numerator multiplied by 6, square root of 6, and my denominator multiplied by square root of 6. So I'm going to get 2, and 3 times 6 is 18. And this is going to be the square root of 6 times the square root of 6, which is going to be the square root of 36, which the square root of 36 is 6. So instead of having to do that, we can just know that this is going to be 6. It's whatever number is underneath the radical. Okay? So now I can break apart 18, right, to 9 and 2. And what is the square root of 9? 3. And 2 times 3 is 6. And then we have 6 over 6, which cancels out. And then we're left with the square root of 2. Okay, so 28 can't go into 7, but 7 can go into 28. So I'm going to show you the other way of doing this instead of just we can reduce down for it. So I can take out a 7s out of both of these, and I'm left with 8 on top, and then 28s cubed divided by 7s is going to be 4s squared. And then what's the square root of 4s squared? 2s. So I'm going to be left with 8 over 2s. And 2 can go into 8, giving us 4 over s. Alright, and we have a your turn here, but we'll just do it together, okay? Alright, so we're multiplying here. So I need to multiply my insides first, or I can reduce first. It's really up to you. I like multiplying first just so that I'm not missing anything. So I'm going to multiply 12a times 6a, and I'm going to get what? 72a. Yep, 72a squared. Now I need to break this apart. So what am I going to break 72 apart into? A good way of doing this is taking 72 and dividing it by like 2, 3, 4, 5, 6, 7, and seeing if the number that you get is a perfect square. 2 and 36, right? 2 times 36 is, and that means that 36 would have to be my largest one because, but 4 is also, 18 can be broken apart. You know what I mean? So that's why you don't want to, I would either work backwards dividing by perfect squares or work forward dividing by just numbers, okay? That's a 2, yeah. Sorry, I don't know why I wrote an S. Alright, and the square root of 36 is 6, and the square root of a squared is a, and I'm left with a 2 on the inside. If we would have done it the other way, I would have been left with an 18 on the inside and would have had to still reduce, okay? Which is fine, you just have multiple steps then, or more steps. Okay, can 12 go in, or can 27 go into 12? What about 12 going into 27? No. Can I break apart 12 and 27? Yes. I can break apart 12 into 4 times 3, and 27 can be 9 times 3. And the square root of 4 is 2, so it's going to be 2 square root 3. And the square root of 9 is 3 square root 3. Okay?
And the square root is cancelled out.
Yeah, so I'm left with just 2 over 3. Alright, how about my next one? Can 3 go to 60? Yeah. So I'm going to divide it. So I'm going to get square root of 20. Can I break apart the square root of 20? 4 times 5? Yep, and then 2 square root 5. Perfect.